Hi, I'm David McLeod.
Joshua Raboin,
Braden White.
and I'll be doing the third problem for the differential equations project, proving it if y e to the x times y prime is equal e to the negative y plus e to the negative 2x minus y is capable of separation of variables, exact or linear differentiation. So I'll start with the separation of variables. So I have to prove if you can get all the bits for the dependent variable on one side of the equation along with the dy, and then all the bits for the independent variable on the other side of the equation with the dx. So to start off with, we're going to go with multiplying everything by natural log to eliminate our e values. So we will have natural log of y plus the natural log of e to the x plus the natural log of dy dx is equal to negative y subtract 2x minus y. Then take this a step further by rearranging the problem a little bit. So we have natural log of y plus the natural log of dy, because we can split this because these two are being divided by each other to be the natural log of dy subtract the natural log of dx. So this will also be added, so the y will come to this side of the equation, and making it plus y is equal to, then we subtracted that over, so negative natural log, well, if you solve that out, it would be x, so negative x, subtract or added that over, so plus natural log of dx is equal to negative 2x. Forgot this y, so that'll come over here as well. This proves out that you can separate the variables. We'd have to put a little more algebra to get the dy here out of the natural log, but the dependent variables are on one side of the equation, put the independent variables on the other side of the equation, so it can be solved. Next, I'll be going to the exact solution, which the exact solution is, can you separate it so that one side of the equal sign becomes a function, which you're going to take the partial differentiation of it with respects to y, and then is that going to be equal to the other side of the equation once you take the partial differentiation of it with respects to x. So it'll look like mx of y, the partial differentiation with respects to y will be equal to n x y with the partial differentiation with respects to x. So these two pieces have to be equal to each other. So we have y e to the x times y prime, well, I'm going to split that, so we have dy dx is equal to e to the negative y plus e to the negative 2x minus y. Again, through pulling things apart, we can split this into two different variables. So we will have y e to the x times dy dx is equal to e to the negative y plus e to the negative 2x times e to the negative y. And right here you can kind of tell immediately that this was not possible, because if you look at these variables, you'll very quickly see that this x and this x, that would be, or once we take the derivative with respect to each other, The fact is that this has a -2 in it versus this has 1, and same as this has a -1 and this has a -1. So once we take the derivative, or the partial derivative with respect to anything, one of our variables will have a -2 being its constant, whereas the other ones will only have 1 or -1, meaning that it is not possible to get this to actually solve out and actually be equal. So it is for sure separation of variables, but exact will not work. Make some more room. Next off, we're going to test if it's a linear function. This will, in order for it to be a linear function, it has to follow the rules of y prime is equal to y prime plus a constant function, p of x, times y, so the original function, is equal to another constant function. Now, this one and this one have to be free of all, the px and the f of x, so the constant functions have to be free of all dependent variables. So, as we're going to find out, this is actually, again, not possible because we will rearrange this so we have y prime of x and then divide this over here. So it's going to be equal to e to the negative y divided by y e to the x, or we could rearrange that again, but plus e to the negative 2x minus y divided by, make that a little darker, divided by y e to the x. So again, we can subtract one of these, either this function or this function can be subtracted to bring it over to the other side to give us our px of y. But the problem is going to be here, we have to get rid of the y in the denominator for one of these two functions because both of them cannot have y in the function. So in order to do that, we'd have to multiply y through, but then that would put a y in with our y prime, which we cannot do. So this will not be a linear function either. And that is it.